Most architects say they use systems thinking. But when you watch their decisions, you see service comparisons, feature debates, cost arguments. That's not systems thinking, that's feature shopping. Today I'll show you the exact model I use when I evaluate architecture decisions in real environments. Not theory, a diagnostic framework. In Episode 1, we clarified what systems thinking actually means. In Episode 2, we applied it to cloud architecture. Now we operationalize it. This is the structured model I use. 5 steps. Every serious decision. Let's make it concrete. You're designing an event-driven architecture on AWS. Decision. One centralized event bridge bus or domain-owned event streams. We will run that decision through the full model. 1. Define the system boundary. Most architects define the system as the event platform. Wrong boundary. The real system is the engineering organization, governance model, platform team, compliance requirements. If you define the boundary too small, you optimize routing. If you define it correctly, you design for behavior. Boundary question I always ask. Where does responsibility actually begin and end? If you cannot answer that clearly, you're designing fragments. 2. Identify feedback loops. Every architecture decision amplifies something. Centralized event bus. More domains, more events, more dependencies, more coordination, more central control. That's a reinforcing loop toward platform dominance. Decentralized streams. More domains, more autonomy, faster deployment, more experimentation, more contracts, eventual need for shared standards. Different loop. You are not choosing infrastructure. You are choosing which behavior compounds. Most engineers see services. Systems thinkers see loops. 3. Identify constraints. Now we ask, what is the actual limiting factor? Not what looks impressive on a slide. In most organizations, the constraint is not throughput. It's governance capacity. If your security team is small, centralization stabilizes the system. If your domains are mature and independent, centralization becomes friction. Constraints shape behavior more than features do. Architectural maturity is constraint awareness. 4. Map delayed consequences. Now simulate time. Centralized bus. Year 1. Clean, simple, auditable. Year 3. Political bottleneck, platform backlog, deployment queues. Decentralized streams. Year 1. Some duplication, more tooling variance. Year 3. Faster domain evolution, but contract management overhead. Delayed consequences are invisible in sprint planning. Architecture is the management of delayed consequences. If you don't simulate time, you are designing for the present, not the system lifecycle. 5. Evaluate decision aging. This is the signature step. How does the decision age? Every architecture choice has an aging curve. Some decisions compound clarity. Others compound entropy. I evaluate aging across 3 dimensions: operational aging, organizational aging, compliance aging. Centralization often ages into rigidity. Decentralization often ages into complexity. So the better move might be decentralized streams with enforced contract standards. Autonomy compounds. Entropy is constrained. That's not a service choice. That's trajectory design. Let's move fast. Microservices versus monolith. Boundary mistake. Thinking the system is the application. The real system is application, deployment model, team topology, cognitive load. Feedback loop. More services, more independent deployments, more operational surface, more monitoring, more DevOps investment. Constraint. Is your bottleneck feature velocity or operational maturity? Delayed consequence. Microservices often accelerate early and degrade into coordination fatigue. Aging. Does your organization scale ownership? If not, the architecture decays. Again, this is behavior analysis, not ideology. What this model actually does, it forces you to expand the boundary, expose feedback loops, identify real constraints, simulate delayed effects, evaluate aging curves. Without this, architecture becomes reactive. With this, architecture becomes predictive. That is the difference between assembling systems and shaping them. Now here's the deeper point, the larger frame. Systems thinking is not the final layer, it's the diagnostic layer. Architecture is not about systems, it's about decisions. Every system is the accumulated result of decisions over time. Which constraints you accept, which loops you amplify, which trade-offs you encode. If this model resonates with you, the next step is not another systems episode, it's the full series. Architecture as decisions. That's where we go deeper into decision metadata, decision decay, governance as a control loop, cloud drift, compounding versus decaying architecture. Systems thinking lets you see behavior. Decision thinking lets you shape it. And architecture is behavior designed over time. Good architects design for scale. Great architects design for how decisions age. That's where architecture becomes intentional. Time is the real runtime environment, and most architects never test in it.